This video will cover hypothesis testing using SPSS. And again, I'm looking here at my combined data from returns 2, which was looking at the annualized returns on a series of load and no load funds. So my first hypothesis that I want to test is HO, the average annual return, is equal to negative 10%. So the average annual return of my combined data is equal to negative 10%. That's my HO. So what I'm going to do is go into Analyze, and then Compare Means, select a one sampled t-test. I'll select my variable as combined, and then I'll select here my test value as negative 10%. Now, I've just done this and the video didn't load, so that's why you see these values typed in, but you will have to type them in yourselves. So negative 10%, and I'm just typing it in as negative 10 because my data is already in percentage notation. And I will click OK. Now, HO, my HO mu is equal to negative 10%. That is a two-tailed test. So all I have to look at here is my significance two-tailed. That's my p-value for my two-tailed. And that is 0.018. So that is not less than 0.05. So I do not reject HO. So I'd say there's insufficient evidence to conclude that the average return on our funds is not equal to negative 10% annually. Now, this is kind of interesting because we get a different result when we used Excel, though we were really close to failing to reject there as well. Next, I want to test the hypothesis. I believe that the annualized return is less than negative 10%. So if I think the annualized return is less than negative 10%, I would test HO, the annualized return is greater than or equal to negative 10%. Now, if HO is greater than or equal to negative 10%, that's actually a one-tailed lower test. It's one-tailed lower because you would reject HO in the lower region of your normal distribution. So it's a one-tailed lower test. Now, default SPSS performs a two-tailed test, and we need to convert this two-tailed result into a one-tailed result. If the t-statistic that you calculate has the same mathematical sign as the tail you are looking at, then all you need to do is take your p-value and divide it by 2. Again, that p-value is that significance two-tail. So here, mu is greater than or equal to negative 10%, tells me that this is a one-tailed lower test. My t is negative, which is in the lower region, a negative low. So they match, right? So all I have to do is take my my 0.108 and divide it by 2, and I'll get 0.054, which says that I fail to reject HO, though I'm really, really close. And I would say that there's insufficient evidence to conclude that the return isn't greater than or equal to negative 10%. Now, it was interesting, in Excel, I believe this one we failed. We may have rejected, but we were really close. I don't exactly remember. You'll have to go back and look at it. But what I really want to focus on here is the fact that since this was a lower tail test and my t was negative, all I had to do was take my p-value and divide it by 2. If this was an upper tailed test, meaning HO said mu0 is less than or equal to something, and my t had still come out negative, I wouldn't just be able to take that t and divide it by 2. I would do 1 minus that p-value divided by 2. If, however, I wanted to do an upper tail test and my p-value was positive, I would just take, or my t-value was positive, I would just take that p-value and divide by 2. So, easy way to remember this, if you want to do a lower tailed test, meaning HO mu is greater than or equal to something, and t is negative, take p and divide by 2. If you want to do an upper-tailed test where HO is mu is less than or equal to something and T is positive, take P and divide by 2. If you don't fall into one of those two categories, meaning you want to do a lower-tailed test and you have a positive T, or you want to do an upper-tailed test and you have a negative T, then in either of those cases you would do 1 minus that P value divided by 2.